Hello students, now we are going to continue in our third video from where we stopped about investigating fuels. Fuels vary widely in their properties, means they are different in their properties. Fuels vary widely in their properties. Hydrogen and natural gas are extremely explosive. Petrol is highly flammable. That means the natural gas are really extremely explosive. That means they can be explode, and petrol is highly flammable. It has a highly flammable. Lumps of a coal and log of wood are quite hard to set alight. Fuels also vary in how much energy they can transfer per gram. They're different from how much energy they transfer per gram. Hydrogen transfer the highest amount of energy, whereas wood transfer the least. So when you burn hydrogen, it gives you a lot of energy, and when you burn wood, it gives you least energy compared to all the fuels you have. Energy in a fuel. The amount of energy transferred by combustion. Burning means burning of a fuel depends on what? The amount of fuel burned. How much energy is stored in a fuel? The amount of energy transferred by combustion, burning of a fuel depends on the amount of fuel burned. How much energy is stored in a fuel? The more fuel burned, the greater amount of chemical energy transferred by heat. The more you burn fuel, the greater amount of chemical energy transferred by heat. The type of fuel will also determine how much energy is transferred. With some fuels, such as petrol, only small amount has to be burned to obtain large amount of energy. So they give an example of a fuel like petrol, such as petrol. Only small amount of to be burned to obtain or to get a large amount of heat. It contrasts a lot of wood has to be burned to obtain the same amount of heat. If you compare wood with the fuel, you need a lot of wood to get the same amount of energy when you burn a small amount of fuel. Difference between fuels. Fuels with the most chemical energy to transfer with produce the highest amount of heat using the least amount of fuel. One way to compare the energy transferred from the different fuel is to burn the same mass of each fuel. That means you take each. So one way, that means you're going to take the same amount of each fuel like petrol and wood, for example, and you burn them at the same time. Use the heat energy to warm the same amount of water, for example, and then you will use a water to heat up, and you see that which warms, say the amount of water, and record the temperature rise of the water, and you see that which water is getting the heat is getting higher. The fuels that transfer the most energy will produce the highest rise in temperature. As you know that fuel is going to transfer the most energy comparing to wood. Interpreting graphical data. Graphs are used a way to compare the energy for the different fuels. Now here they're using graph to compare different different fuels. Different type of graphs show data in different way. Look at those figure 1.6.9b which present the data from the table. Now you have a table and then you have a graph. Hydrogen fuel, it provide 143 kjoules. Petrol 46, diesel 45, aviation fuel 43, paraffin 42, natural gas 37, coal 33, and wood 12. Now this been compared, they have shown this one into a chart form, and this is a pie chart. Combustion, as I said, that a reaction of the fuel with oxygen that produce heat. Move to another topic, which is exploring sound. Exploring sound. Sound is hugely important throughout the animal kingdom as means of communication, location, and defense. So sound is really important, hugely important throughout the animals. For animals kingdom means like forest or in zoo, because they need to communicate, because they use the only source, because they cannot talk like us as humans. So the only source of is that sound. They use it for communication, for the location, for identifying each other's locations, and for defense. Making sound. If you place a finger over your voice box, then speak or sing, you will feel the voice box vibrate. That means if you put a finger on your voice box, you will feel there is vibration. If you place a finger over your voice box when you speak or sing, you will feel a voice box vibrate. This where the sound comes from. This is the place from where your sound comes from. When an instrument is plucked or blown through the string or the air vibrate, often the vibrations are too small to see. You cannot see, too small to see. All vibration result in a sound. That means sound is made from what? Sound is made from vibration. The vibration from the object are passed on to the air particles. So the vibration move to the air particles. These air particles bumps in together. That means the particles in the air, they will start bumping together. When they bump together, the wave progress, the wave moves. Eventually, the energy of vibration transferred to the air, and that energy has been transferred into your ear. It's been or generate the sound. So the vibrate sound is made by vibration. So vibrate, backward vibrates what backward or forward movement. That's the meaning of vibrate or vibration. Making waves. Energy waves. Energy is transferred by sound in a form of waves. Energy is transferred by sound in a form of waves. In figure 1.6.11b, a slinky spring provides a model that shows how these waves work. Here, they are showing how the waves works. When you push end of the slinky back and forth, some of the coils squash together and other pull apart. The wave of energy along the length of the spring. A wave is like which travels in a same line as a vibration source is called longitudinal wave. That means the wave like which travels as a vibration of a source is called like longitudinal wave. Now what's longitudinal wave? The wave in which the vibration are parallel. That means they are same. The waves are same, are parallel to the direction in which the energy is transferred. Source of move, you see this one is left and this one is moving rightwards. So when the slinky spring provide the model that shows here, so when the push the end of slinky back and forth, some of the coils squash together, and they're squashing together, they are generate vibration, and other pulls apart. The waves energy pass along the length of the spring. That means the wave pass along the length. The wave is like equal, travels in a same line as vibration of a source is called longitudinal wave. Now why it's called the longitudinal wave? Because the wave in which the vibration are parallel to the direction, because the waves are parallel to the direction in which energy is transferred. Sound waves work in the same way. Vibration push air particles together and also pulls them apart, creating a longitudinal wave. So even in air it works. Sound waves work in the same way. Vibrations push air particles together and also pull apart, creating a longitudinal wave of an energy. The energy passes from the source of vibration to our ear. Louder and quieter sound. Sound can be louder by increasing the energy in the vibration. More the energy, more vibration, that means you will have louder sound. Plucking a string harder, blowing harder through a wind instrument, or beating a drum harder will all transfer more energy. The louder sound is measured in a unit called decibel or dB. The loudest sound that humans can listen, the loudest sound that human can listen is what? Without damage their hearing is about 120 dB. So the limit of humans listening is 120 dB. The size of vibration is represented in amplitude. The size of vibration represented in amplitude. They have seen in figure 1.6.11d shows that the amplitude is maximum distance. The greater the amplitude, the greater the energy of the vibration and the louder the sound. So greater the amplitude, the greater the energy of the vibration and the louder the sound. In other words, the bigger wave will transfer more energy and be heard loud sound. You can see here in the picture source of sound. You see air particles being moving. Vibration in a particles. Sound wave progress as a particles bumps into one another. Amplitude is a distance. Amplitude of vibration here is a distance. A maximum displacement of a point of wave. That means from where this point moves, this movement is known as amplitude. I'll show you here. See here, this is longitudinal wave. A motion of a particles in a parallel to the direction of the wave progressing. Mechanical waves traveling through a gas or always longitudinal. You can see here these two waves, they are parallel, they are equal to each other. Speakers, it generates a sound emitted. Now transceiver waves, this another type of wave, this is known as transceiver waves. Motion of particles, you can see direction of the waves, how it's been moving. Complex wave in water, see here water waves, how it travels. These waves are longitudinal transceiver at the same time, so they are moving at a same time of the water moving circle. You can see here how these particles are moving. Polarization transceiver component waves here. So these are, I'm just showing you, haven't you familiar with the complex wave and longitudinal wave. So these are some electromagnetism wave. This is electromagnetism waves and this is your gravitational waves. So you have different type of waves. You're going to study this in grade 8, 9 and 10. So for here it's just you have to know about longitudinal wave. So it's a parallel, the motion of the particles in a parallel to the direction of the waves. Propagation mechanical waves traveling through the gases are always longitudinal. So let's come to vocab. Vibrate. What's vibrate? A backward or forward movement is known as vibration of a particle. Longitudinal wave, the wave in which the vibration are parallel to the direction in which energy is transferred. dB or decibel, unit of sound, loudness. The unit of sound, loudness. Amplitude, a maximum displacement of a point on a wave from its undisturbed position. That means here amplitude vibration, that means it from here to here. That means this is its undisturbed position, and from this undisturbed position to disturbed position until here is known, this distance is known as amplitude. Okay, let's move. Describing sounds. There are many different type of sounds. Think of the sounds made by whale compared with the high-pitched screeching of a monkey, or the sound of the bass guitar compared with a violin. Difference in sound arise from the different characteristic of the sound. So different sounds means different vibration, different waves. What is a pitch? Is a ship horn produces a sound that is very deep and low. This is known as a low pitch. So a horn produces sound that is deep and low. This is known as a pitch. The pitch is a note is also called as a frequency. The other name of it is also known as a frequency. What's a frequency? The numbers of waves passing a set point or emitted by a source in a second. Numbers of wave passing is known as frequency. A high frequency means the pitch, and a low frequency means low pitch. So high frequency means high pitch and low frequency means low pitch. That means when you have low numbers of frequency, it's called as low pitch, and when you have high, it is high pitch. Musical note change in pitch by changing the frequency of vibration. How you can change the frequency? By increasing the vibration. More vibration, more frequency. Less vibration, will have less frequency. We'll come back to it later. Now, frequency, wavelength and amplitude. Sound wave can be represented in a diagram like that shown in figure 1.6.12b. The curve, or a waveform, is a graph of a displacement of the air particle at a different distance along the wave. The wavelength is the distance along the wave from one point to next point, where the wave motion begin to repeat itself. So you can see this is amplitude, how this is wavelength. Amplitude is from here. This is an amplitude, how curved it is. Wavelength is from one point to another, from here to here. You can see how curved is an amplitude, and the wavelength from one to another. Wavelength is a distance along. Wavelength is a distance along a wave from one point, this point, to the next point here, where the waves motion being repeated itself, and after that it will repeat itself. Okay. The higher the frequency of the wave, the shorter the wavelength. So higher the frequency, that means more your amplitude, the distance between these two will be smaller. Okay, let me highlight this part. The higher the frequency of wave, the shorter the wavelength, and the high frequency means more vibration are produced per seconds. Maximum displacement is called amplitude. The maximum displacement is called amplitude. The energy transferred by the wave depends on this. The larger the amplitude of the sound wave, the louder the sound. That means the larger amplitude of sound wave, the louder the sound. Higher the frequency of waves, that means this one, the curve, higher the curve, the length will be smaller. Here we have more amplitude. Higher the frequency of wave, the shorter the wave length. High amplitude and short wave length here. Interpreting the sound waves. All sound waves can be detected by using microphone. All sound can be using detect microphone and shown as a waveform on a screen. Microphone receives, that means the role of microphone is which receives the sound wave and convert them into electrical signals. Detectives use tracers like these to match voice pattern from recording to know a criminal or identify patterns from the shot of a particular gun. Come see if it's working. Sorry for that, students. So here, this is a 3D diagram, that means wave formation, how wave is being formed. See here, wave particle, these are the particles. Say wave particle, these are the particles. Wave front, a surface made up for particles vibrating in the same phase. And wavelength, as I told you, from 1 to here, this is known as wavelength. Wave speed, particles here, speed of the waves. Frequency, you can see a different frequency, you can change the frequency, you'll see that particles is moving differently. 40 slash 1000, see, is getting, so this is much faster. So you see that how the particles have been changing. See, 200, 1000 and 5. Amplitude, this is how the wave, this is an amplitude. What's an amplitude? Repeating, maximum value of 1 of a vibration per meter. In case of the sound, the amplitude is usually identified with a maximum value of air pressure or displacement. Amplitude is directly related to intensity of the sound. The higher the amplitude, the louder the sound. As we said, that higher amplitude, the louder the side. It is the independent of the frequency and speed of the sound. This is an amplitude. You can see the purple. This is an amplitude. Phase, you have different phases at 90 degree. You can see how it's been changing. Waves phase, phase difference between two vibrating particles that are in phase 0 and 180 between particles at an antiphase. Then 1 degree, see that how it changes. Now let's move to here. Need to finish with the, so frequency is a number of waves passing a set point or emitted by a source in a second. Waveform. Now what is a waveform? A graph of a displacement of a motion at a different distance along the wave. Waveform, that means how the wave is being formed. Wavelength, I've explained here. Wavelength, let's convert, this is a wavelength, for example, how it's been good, it will go. This is a wavelength. It's a distance along a waveform on a point to the next point where the wave motion being to be repeat itself. What's a microphone? Is here again. All sound waves can be detected using microphone. Microphone, it receives the sound waves and convert into electrical signals. So the role of microphone is what? It takes the sound waves and convert them, means change them into electrical signals. Measuring the speed of sound. Echo are used by bats and dolphins to navigate, find a prey, and find mates. So they use echo. Now what is an echo? A reflection of a sound. It reflects back. It goes and it comes back to them. Echo are used by bats and dolphins to navigate, to find their mates, their friends, or prey. Dolphins can tell the difference between the golf ball and ping pong ball by using echoes. And bats can detect tiny insects in pitch black darkness. Humans have learned from these creatures to use echo in similar ways. Now, sound waves. Sound waves can bounce back. Sound waves can bounce back from surface, well called in reflection of the sound and echo. So that reflection of the sound is known as echo. Hard surface will reflect more sound. If the surface is hard, it will reflect more sound. Surface making stronger echo. You will have stronger echo. For example, if the room is empty, there's no furniture. When you talk, you will see. Sorry, students. You will have more echo. Shouting across a rocky outcrop in a long tunnel can produce more echo. That means if shouting in a tunnel, it will produce more echo. Echo transfers less energy back to a listener, so is quieter than an original sound. This is because some energy has been transmitted as heat materials in it is reflecting form. Sometimes it says some transfer less energy to the listener, so is quieter than the original. So it is a bit quieter, means than original sound, because some energy has been transferred into heat in materials it is reflected. That means it reflects into, for example, a wall or something. It will absorb less energy, a bit of energy, and it will come back. So it will not come as the original sound. Give you example of this one. Let me show you how a bat use its echo. Come on. You can see here is a bat. Now when it hunts, let's say in a dark, see it's using its echo. Now the echo is coming back, reflection is coming back. This is known as echo, to know its prey. See, repeat. The echo is going and it's coming back. So a bat can know where the prey is. Here you can see here. This is how, so it can know the distance with the help of echo. Hibernation. This is what you have to know only. So this is how it works. Measuring the echo. An echo is reflection of the sound wave from surface including back towards a sender. So echo is a reflection of the sound wave from a surface including backward to a sender. Echo travels twice the distance from the sender to a surface. When echo from a sound wave back, it can be calculated. The speed of sound is equal to total distance traveled by an echo and time taken. That means how the distance of the echo and how much time it's been taken. For example, when there's an echo going, it will measure. That means how much time it will go, how far it will go, and how much time does it took to come back to a listener. See, if there's another example of it, you can see that distance, that means this is a wall, how much distance between them from a person to a wall, and how much time it took back so he can listen this voice again, an echo. So speed sound total distance equal to total distance traveled by echo and time taken. Naval ship use sonar. Now what is a sonar? A technique used on a ship to measure the depth, that means how deep below the ship by detecting reflected ultrasounds. Naval ship use sonar to locate hidden submarines. They send sound waves through the water from a ship. Naval ship use sonar to locate the hidden submarines. They send sound waves through water from a ship. The ship's sound wave reflects off the sea floor and return to ship as an echo. If the submarine is located under the passing ship, the echo returns quickly because the sound has shorter distance to travel. So if it's under it, so depends on the distance. Fishermen also use this method to locate a shoal of a fish. The speed of the sound through the water is 1500 miles per second. When calculating the distance of the object from the boat, remember that the sound waves travel to the sea bed and back again. So distance of the object to the boat, half multiply speed of the sound times time taken. Let me show you one more 3D video. As you can see here, the ship. See from here. Bottom. Sound radar. This is a sonar, how it works. You can see here. This is how a sonar works. This is your sonar. An echo. You can see that sound wave is coming. Sound wave and echo is coming back. Sound wave and echo is coming back. This is how it can know. This is a sonar. So if the object is here somewhere, is clear, depend on the distance to know the surface. Or if there's a submarine, so if the submarine is under the ship, so it will go less distance and it will come faster. So it measures the distance between the sound between the echo sound wave being gone and the echo, the distance and the time taken by an echo. You have a side scanner sonar. This is used here, side sonar scanner and towing cable, for example here. Mapping and detecting, you can see here. Coming back to this one, you can see how echo works. This is your sonar. The role of sonar is sends the sound waves and the echo come back. So this was how it works. So reflection, when waves such as sound or light bounce back, is known as reflection. Echo, reflection of sound waves. Speed of sound, the speed at which the sound waves travels. Sonar, as I showed you now, a technique used on a ship to measure the depth, how deep below the ship by detecting reflected ultrasound. So we'll continue in our next video more.